In this video we have two integrals to evaluate. So for the first one we have the integral of x to the third over x squared plus 1. Now this is a rational function here for the integrand, but the degree of the numerator is larger than the degree of the denominator. So in this case, the better option here is to divide long division. So we got x to the third divided by x squared plus 1. So we divide x squared into the x cubed and we get x here. Multiply the partial quotient here by the divisor. X times x squared is x cubed. X times 1 is x. And then we subtract here. X cubed subtract x cubed cancels, and here we're actually subtracting from 0. 0 subtract x is a minus x. Degree of the divisor, or the remainder I should say, is less than the degree of the divisor. So we can stop right there and rewrite the integrand. This then would be the integral quotient is x, and the remainder is minus x, so this will be minus x over the divisor. This will be x squared plus 1. This will be dx here. Now you can break this up into two integrals, or you could just integrate term by term here. Say the integral of x with respect to x here. Add 1 to this one, we get x squared. Divide by 2, we get that. And notice for the second one, the denominator is x squared plus 1. If you take the derivative of that, you get 2x. And you got the x right there. This been a 1 to be a different situation, but here you can use the standard U-substitution. So basically, if you can do it in your head, you go ahead and do it. Or you can just say let u equal to x squared plus 1. Then du would equal to 2x dx. Divide here by 2. This cancels out. 2 over here. So the x dx can be replaced by du over 2. So I'm going to do this on the side over here. This will be du, then the 1/2 I put it right in front. And this is here, u right here. And we still have the minus 1 there. And of course you have your main formula here. Integral of du over u is always absolute value, for the natural log I should say, of the absolute value of u. And then you have the 1/2 right here. Now we complete this, then we have the minus there. This will be a minus 1/2, and it's natural log of absolute value. But notice here the u is x squared plus 1. That cannot be negative. So we don't need parentheses here. Let's just write this as minus 1/2 natural log of x squared plus 1 plus the constant of integration. So that's your final answer, x squared over 2 minus 1/2 natural log of x squared plus 1 plus the constant of integration. Let's go on to the next one. Now anytime you have the square root of a difference of squares, or you can write it as the difference of squares, then you usually going to have a trig substitution possibility. And there's also formulas that lead to arc trig functions. For example, if you have the integral of, say, du over the square root of a squared minus u squared. If you have something in this form, or something that you can write in this form, du over the square root of a squared minus u squared. A is a constant here. U is just going to be a function of x. Notice right here. Now for this particular one, because the derivative of x plus 1 is 1, I can go directly to this formula right here. In other words, I could say my du is the same thing as dx, and the u is the same thing as x plus 1. And the a is 1, because this could be written as 1 squared. So I could just go write the answer using this formula. Well, let me complete the formula. This is equal to arc sine of u over a. And this is plus the constant of integration. So again, I can go directly to the formula then. Using that formula here, that's in that particular form. This is arc sine of u over a. In our case, u is x plus 1. and a is 1 squared. So this would be x plus 1 over 1. This is going to give me x plus 1 plus the constant of integration. Now, if you want to put it exactly in this format, you can do this. You can say, well, let's let u equal to x plus 1. Then du is equal to the derivative of x plus 1, which is 1. So this would be dx. And then you can go back and rewrite it if you want. And instead of dx, then that's going to be your du. Instead of x plus 1, this is going to be your u. And of course, the a is 1. 1 squared is 1. And then it's u, which is right there, over the a, which is 1, plus the constant of integration. But this one is just so clearly written here, the way it is. And okay, it works out like this because the derivative of x plus 1 is 1. Anyway, this is your answer for this one. Thanks for watching. We'll see you next time.